Hey y'all, welcome to the last video of Unit 1, and we're going to talk about concept number 8, polygons. So you should know some of this, I think, from the past, and some of it should sound new. Either way, let's talk about a polygon, and it's a closed plane figure, and all that just means that it's two-dimensional, it can be flat in a plane, and it's closed. That means if you look down here, all of the sides join together. And all of the sides of a polygon are segments, and in order to have a closed plane figure that makes a polygon, we have to have three or more segments or three or more sides. And when these segments come together, they'll form two types of angles. One would be an interior angle, as shown there, and the other type is an exterior angle, which we need to extend one of the sides, and that exterior angle is formed by a side and that extension. So that right there in blue is an exterior angle. Notice this polygon has 6 sides. It also has 6 interior angles, and we can draw 6 unique exterior angles. So a polygon has the same number of angles inside and outside as it does sides. Here are some of the common polygons you're going to be asked to know the names of. Some of them should look familiar, some of them maybe not. And we go up to 12 sides, which is a dodecagon. And this n-gon stands for any other type of polygon that we don't have a specific name for. So n actually represents the number of sides. And that's not a hashtag, people, that means number. Okay? So if we have a 36-sided polygon, we can call it a 36gon. It might have a specific name, I'm not sure of it, but we can call it a 36gon. So pause the video and make sure that you have the names of all these polygons written down somewhere. Our first theorem for talking about polygons, we'll talk about the angle sum. So if we take all of the interior angles of a polygon and add them together, that's where we get the sum. That should be equal to 180 times the quantity, so in parentheses n minus 2. And again, just a reminder that this n is the number of sides. So if we want to know the sum of any polygon, the sum of the interior angles, we just plug the number of sides in there for n, simplify that number minus 2, and multiply by 180. So pause the video here and find the sum of the interior angle measures of a heptagon. So if you pause and try this problem, you should get that the sum of the interior angle measures of a heptagon is 900 degrees, and that's found just by plugging the number of sides, and a heptagon has 7 sides. Plug that in for n, simplify, and get 900. We have a special type of polygon that we're going to talk about, and that's a regular polygon. In a regular polygon, all of the sides and all of the angles are congruent. So all of these sides on this 5-sided pentagon are the same length, and all of the interior angles are going to be congruent to each other. So they'll all have the same measure. And if we extended all these sides and found the exterior angles, all of the exterior angles would also be congruent to each other. So if we know not a triangle, any polygon is a regular polygon, then we can find the measure of one interior angle. So we'll take that formula we had, 180 times n minus 2. That was the sum of the interior angles of any polygon. If we know that we have a regular polygon, we can just divide that by n, the number of sides, and that'll give us the measure of just 1. And I did make a spelling mistake here, so if you're paying attention, hopefully you caught that. I needed to add a little r in there. So I apologize for the spelling mistake. Make sure you fix it on your paper. So let's try using that formula and find the measure of one interior angle of a regular nonagon. So if you knew that a nonagon had 9 sides and you plugged into the appropriate formula, like I did here, and you simplified correctly, you should get that one interior angle of a regular nonagon is 140 degrees. Here we have a theorem. It doesn't have a formula like the last couple formulas, but you should know that the sum of the measures of any polygon of the exterior angles, so all the exterior angles of any polygon, if you added them all together, they always, and that's why I put it in red and bold here, and I'm underlining it, always add up to 360 degrees. So now, using that information, if we know that a polygon is a regular polygon, we can find the measure of one exterior angle, just like we did for one interior angle. And all we need to do is take 360 degrees, because we always know the sum is 360, and we can divide it by n, the number of sides. So pause the video and try this example using the exterior angle formula. So if you knew that a hendecagon had 11 sides, and you plugged in here 11 for n, the number of sides, and simplified, you should get that each exterior angle is 32.72 repeating degrees. So we possibly could round this to 32.7 degrees. I have 3 questions for you on the U-Tries. Be sure to submit your answers online by clicking the link in the description section of this video. Click the link below rather than typing it into your web browser, and that should eliminate any problems you have trying to get to the submission form. And good luck.